But what exactly is cloning? Simply put, it's the creation of an organism that's genetically identical to another. It's like nature's own copy-paste function, but performed in a laboratory. And while Dolly may be the most famous clone, she's far from the only one. Mice, cats, cows, and even dogs have been successfully cloned, proving that this technology is not confined to the realm of sheep. But it's not just about creating carbon copies of our favorite pets. The potential of cloning extends far beyond that. Think about it. A world where endangered species could be brought back from the brink of extinction, where organ transplants are not limited by donor availability, where the medical mysteries of genetic diseases could be unraveled and potentially cured. Imagine the possibilities. A world where the promise of cloning could revolutionize medicine, agriculture, and conservation. A world where we could, quite literally, replicate success. But despite these potential benefits, cloning is not as commonplace as one might expect. It's a technology that's been met with a mix of awe and apprehension, fascination and fear. It's a world that's on the cusp of a new frontier, yet held back by numerous challenges. So, with all this potential, why isn't cloning more widespread? In order to understand why cloning isn't commonplace, we first need to delve into the science behind it. Let's start with the basics. What is cloning, really? To put it simply, cloning is the process of creating an exact genetic duplicate of an organism. The most common method of cloning, and the one you've likely heard of, is somatic cell nuclear transfer. Here's how it works. First, the nucleus, which houses the DNA, is removed from an egg cell. This egg cell is then fused with a somatic cell. That's any cell that isn't a sperm or egg cell, from the organism to be cloned. The somatic cell's nucleus, containing the organism's DNA, is transferred to the egg cell. When the cell begins to divide, voila, we have an embryo that is genetically identical to the original organism. However, the process is far from foolproof. In fact, it's fraught with challenges. For one, the success rate is remarkably low. Out of hundreds, sometimes thousands of attempts, only a handful of embryos will develop to the point where they can be implanted in a surrogate. And even then, there's no guarantee that the embryo will develop into a healthy individual. Moreover, animals cloned through this method often suffer from health issues. Dolly the sheep, the first mammal cloned from an adult cell, was born with a form of lung disease and arthritis, conditions not typically seen in sheep until much later in life. This has led many scientists to question the viability and ethics of cloning, particularly when it comes to cloning humans. One of the biggest hurdles in cloning is aging. The age of the somatic cell can impact the lifespan of the clone. In other words, if you clone an organism using a cell from late in its life, the clone may not live as long. So while the concept of cloning is certainly fascinating, the science behind it is complex, fraught with challenges, and, quite frankly, still a little out of our reach. Clearly, cloning isn't as simple as it seems in the movies. But it isn't just the scientific hurdles that make cloning a contentious issue. Diving headfirst into the ethical maze that is cloning, we find ourselves facing questions that go beyond the realm of science. One of the primary concerns revolves around the potential for abuse. With the power to create a genetic duplicate, one might be tempted to exploit this for nefarious purposes, such as creating an army of clones for warfare, or even illegal organ harvesting. Then, there's the thorny issue of a clone's rights and identity. Would a clone be considered a separate individual with their own rights and freedoms, or would they be seen merely as a copy, a shadow of the original, devoid of a unique identity? These questions harken back to the age-old debate on nature versus nurture, and whether our genes alone define who we are. The scientific community continues to grapple with these ethical quandaries. Some argue that the potential benefits of cloning, such as organ transplantation or the study of genetic diseases, outweigh the ethical concerns. Others, however, caution against playing God and warn that tampering with nature could have unforeseen consequences. This debate extends beyond the labs and into society at large, where public opinion remains divided. Some view cloning as an exciting frontier in scientific advancement, while others see it as a violation of natural law and a potential source of societal upheaval. This discord underscores the need for comprehensive regulations to ensure that any advancements in cloning are guided by an ethical framework that respects the rights and dignity of all life forms. However, it's worth noting that these ethical concerns, while valid, are based on the assumption that successful human cloning is possible. As of now, the science of cloning is far from perfect, with a high rate of failure and the potential for serious health problems in cloned organisms. The ethical implications of cloning are as complex as the science itself. As we continue to explore this brave new world, we must tread carefully, balancing the pursuit of knowledge with the respect for life and its inherent mysteries. Scene script. Despite these challenges, the future of cloning is far from bleak. Let's dive into the ongoing research and advancements in the realm of cloning technology. The scientific community is continuously pushing boundaries, and breakthroughs are happening at a faster pace than we can imagine. Imagine a world where organ failure is no longer a death sentence, but a problem that can be solved with a clone of your own healthy organ. This future may not be as far off as we think. Scientists are making strides in the field of therapeutic cloning, using a patient's own cells to grow replacement organs. This could revolutionize transplants, eliminating the need for organ donors and the risk of organ rejection. And it's not just about us humans. Cloning technology could play a pivotal role in the conservation of endangered species. In fact, it already has. In the past few years, scientists have successfully cloned several endangered species, giving them a fighting chance against extinction. The potential to preserve biodiversity and restore ecological balance is immense. But the possibilities don't stop there. Cloning could also be a powerful tool in genetic disease research. By cloning cells with specific genetic disorders, scientists can study the onset and progression of diseases in a way that was previously impossible. This could lead to new treatments or even cures for some of the most devastating genetic diseases. Yet, with every advancement, new questions and challenges arise. The ethical implications of cloning are complex and multifaceted. Each step forward requires careful consideration, not just of the scientific implications, but also of the societal and moral ones. It's a delicate balance, but one that we must strive to maintain as we venture further into the future of cloning. While the future of cloning is uncertain, its potential is undeniable. So, what does this all mean for the possibility of cloning your own body? Reflecting on the information we've delved into, it's clear that the concept of personal cloning is not just the stuff of science fiction, but a reality that could be within our grasp. The potential benefits of this technology are staggering. Imagine having a readily available source of donor organs, perfectly matched to your genetic makeup, eliminating the risk of rejection. Or consider the potential for studying genetic diseases by observing how they develop in a clone. Yet, with these benefits come equally significant drawbacks. The process of cloning is still fraught with uncertainties and complications. It's not a perfect science, and the risk of producing clones with serious health issues cannot be ignored. Beyond the practical considerations, cloning your own body also raises profound philosophical questions about identity and individuality. If you clone yourself, is your clone you? Or is it a separate entity entirely, with its own thoughts, feelings, and experiences? This question strikes at the very heart of what it means to be an individual. It challenges our understanding of identity as something unique and unrepeatable. If we can duplicate ourselves, then what becomes of our sense of self, our uniqueness, our individuality? Moreover, there's the ethical dilemma of creating a life solely for the purpose of benefiting another. Is it right to bring a clone into existence, knowing that its life might be burdened by health problems or by the expectations of its genetic predecessor? These questions don't have easy answers. They require careful thought, open dialogue, and a willingness to confront the unknown. The science of cloning is advancing at a remarkable pace, and it's crucial that we, as a society, keep up. We need to understand the implications of this technology, to weigh its potential benefits against its risks, and to grapple with the profound philosophical questions it raises. In the end, the reality of cloning is as fascinating as it is complex, and its future remains to be seen.